I can hear you. Can you hear me?
Oh, brilliant. Hi.
Hello, Roy.
How are
Hey.
you today?
I'm good. Yeah, it's very exciting to do a remote talk.
Good. Yeah, no, it is exciting. We've been having a great time doing this event. It's very different for us, but it's been a great experience. Thank you so much for being part of Swift Heroes Digital.
Thank you. It's very exciting.
Where you're going to be speaking to us today about implementing coroutines. Is that correct?
No, so implementing a component library.
Well, it's the.
There we go.
It's the
That's
same,
why we
it's
check.
It's the same thing. No, it's
Yeah,
not.
just in
But
case.
don't worry.
Okay, so tell us the title of your speech again then.
So it's about implementing a component library, which is a library of UI components in your app.
Perfect. Okay, there we go. Introduced by the man himself. Roy, have a great presentation.
Thank you.
Thank you, Roy.
Thanks.
Okay. So, switch to my screen. All right. So we're going to talk today about implementing a component library.
Just a second.
Right. So we're going to talk today about implementing a component library, and this is the socially distant edition. It's the first time I'm giving a talk in this type of scenario, so please bear with me if something breaks or. I work for Spotify. We make a music and podcast app, and more specifically, I'm working in a team called Origami, and as a team, we look after the mobile part of Encore, which is our design system and component library. And in the time, I've been working a lot on the component architecture and how we build a component library, and today is really about sharing some of the insights from that experience with you. I actually gave a talk on a similar topic last year at ADDC conference in Barcelona. And that talk was a bit more high level, a bit more on the design side. And today, because we're at Swift Heroes, this is going to be a technical talk. And we're going to look at quite a lot of code on how to implement this type of things. So the agenda for today is we're going to go together on a journey of building a component library for a hypothetical app. We will learn through that experience and illustrate lessons around modern component architecture, design, and tools. And we will talk a bit about the real-life challenges of trying to implement this type of thing in your company. I'll have these blue takeaway slides. These are things that you can take away and try and implement in your day-to-day situation. All right, let's get started on the journey. So we're here at Swift Heroes, and in this time, especially, I think heroes are very important and are not celebrated enough, so we're going to build a Heroes app. In the Heroes app, you'll collect your favorite heroes, and what you need to know about the app, it's implemented in Swift. It supports iOS 12 because it's been around for a while, so we can't use all the cool combined stuff Shai showed us. And the app looks like this. So we have 4 tabs. There's a superhero tab, literary hero tab, sandwich hero. This is like a bit of a weird one. It's the Subway type of sandwiches. And we have settings as well. And we get a message from the CEO that we're starting work on Heroes 2.0. So what does Heroes 2.0 look like? Basically, we have a bunch of cards that show us the heroes that we've collected. In this case, superheroes. The cards look pretty much the same on all of these 3 screens. We have an image, a title. The subtitle is what's different. So for superheroes, we have the cinematic universe they belong to. For literary heroes, it's the book that they come from. For sandwiches, there's like a star system. So this feels like a good candidate for a shared UI component, and we're going to create a picture card because it's going to be reused for all of these things. It looks kind of the same. And we'll implement this picture card a bit naively. We'll just create a UI view, create the subviews that we need, and then we'll have an initializer that takes in the title, subtitle, image. And when we put it all together, yeah, it looks the way we expect it to. We see the cards, and people are happy with that. We got a message from a designer and wanted to switch from square images to circular images. And this is something that's very easy to do with our shared components. So we have this view shared on different screens. If we just want to have circular images, yeah, we can create a function, apply a circular mask. And the nice thing is it's going to be carried out everywhere, and it looks the way our designers expect. So we got a lot of value right now from the component library. We made a global change very easily, carried across the whole app, and we feel really great with ourselves. And then we get a message from a PM saying that users don't understand literary heroes, and can we add a book icon below the image? Okay, so making global change was very easy, but now we need to make a change to our component that's only for one of the specific use cases for the component. And there are various ways of doing this, and we want to create a component that's reusable, that's generic, so we'll choose a reusable and generic way. So let's see what that looks like. We basically add an accessory view to the initializer, and the accessory view gets put next to the subtitle. And what happens is basically this. So we have in the literary card, we put an icon there, put it next to the subtitle, and see that on the screen. And time passes. And in that time, people download the app, it grows, we have some user testing. And got a message from the designer that the contrast for the book icon is not great, and we should add a shadow to it. So this is very easy. With our generic accessory view, we can, since it's an optional, we can just, if it's there, add a shadow to it. And yeah, that looks much better. We have the contrast that we expected. But then something weird happens. So we get a message from the colleague at here saying that our settings changed unexpectedly and the switch in settings suddenly looks different. So this is not something that we expected to happen. But turns out that while the time passed, this component that we created, the picture card that was very generic, ended up also being used in settings because they have slightly similar UI. And this generic accessory view that we created ended up being used for a switch. So in this case, the switch got the shadow that we wanted to add for the book. And I know it doesn't seem like a huge deal. It still looks okay. But this is an unexpected visual change, an unexpected regression. And there could be situations that have like much bigger consequences than this. So what happened here is that the picture card that we created could have been used for anything, and it was a bit too generic. So what we need to do is create a much more explicit API for our picture card. One way we can do that is to make the picture card implementation private to our component library and expose very specific APIs for the components. So we can create components for literary hero, for superhero, for sandwich hero, that have, the literary hero has a book that it belongs to, superhero has the universe, sandwich hero the filling. And still underneath, we're using the picture card for the view, but as a user of the app, you see three components. So what we've done is we went from one very generic component to three very specific components. This seems a little bit counterintuitive when you're thinking that our goal with the component library is to reuse as much code as possible and make things as generic and consistent. Why do we end up with so many components? At Spotify, we've been actually on a similar journey. So Glue, which was our component library that we started 7 years ago, when that was created, we looked at the app and saw that there were a lot of rows in the app. So it's one of the most common UI components. And we use rows for things like albums and playlists and podcasts and radio shows. And when the designers and engineers who were working in Glue looked at that and wanted to reuse and be as consistent as possible, what they basically saw was this. They saw that we had something on the left, something on the top and bottom, and something on the right. And they created an entity row. And it ended up being very, very useful. It got used for a lot of things in the app. It got used for profiles and devices. And what happened was that it became very hard to make changes without like unknowingly breaking something somewhere. So with Encore, we went on a similar journey as to the one that we did with Heroes. We went from an entity row to having very specific APIs for playlist row, podcast row, album row, artist row, etc. I think something that's important to mention and be clear about is that we're still reusing things. It's just the API that's specific, but here the view itself is still this generic picture card that exists. We call this idea semantic components, and it's a very critical idea for our component library. And this is the first takeaway from our talk, that first of all, naming is important, both for discovery of components, but also for people knowing how to use them and how do you intend for them to be used. And then if we define components semantically with explicit APIs, we can guide usage and avoid unintentional side effects. This feels like a big learning, so we can raise a toast for ourselves and celebrate. Then we get a message from our colleague that we're launching historical heroes now. That's a new feature in the app. And for historical heroes, because it's characters from history, we don't have great photos of them. So we're going to have, instead of the image, we're going to have a label that says what century the hero belongs to. And the colleague wants to modify a picture card. And this seems like a reasonable use case because, again, we created this picture card to represent heroes. So our colleague goes into the code and makes a change. So now picture card, instead of taking an image, we're going to take an enum with a top view type. And it can be either an image or a text. And then we adjust the UI accordingly. And this is okay because it's aligned with what we want. But over time, we're going to launch more and more heroes. We're going to have space heroes and movie heroes and design heroes and green heroes. And all of these will be slightly different and will need slight modifications to this picture card that's shared. And what will happen is that over time, picture card will grow and grow for all of these different use cases. And again, be hard to make changes to. And as complexity goes up, speed will go down, and our component library will become significantly less popular. So what can we do about it? If we think about the journey we've been into with the API, where we went from the picture card to very specific APIs, could we do the same thing with the UI? Could we go from a picture card to having a literary picture card, super picture card, sandwich picture card, historical picture card? So I would say no. And the reason for that is that, again, one of the main benefits that we wanted to have is this ability to make global changes. And if we created all of these views, if they use inheritance, we can only affect the part that's inherited. And if we don't, then, and they're just copy-pasted, there's no way for us to make global change. So this takes away one of the big selling points of our component library. So what can we do instead? Let's look at our component and what it's actually made of. So there are a few parts to this. First one, we have a styled image. That's the circular one. We have a styled title. That's the one underneath. Styled subtitle. A background, which is the gradient with the rounded corners. And we have a layout, which is basically taking all of these things and putting them together into the shape you see on the screen. So let's look at the picture card. And we're going to extract all of these different things. And first, we'll extract their usable views into their own functions. So we'll create a function that creates the gradient, the styled image, style title, subtitle. Now we want these functions to be reusable from outside of the picture card context. So we're going to move them into a namespace enum. And we're going to make them static functions on that enum. So now we have views, cards, static function gradient, image, title, subtitle. The next step is, rather than initializing the subviews as properties, what we should do is actually inject them from the initializer. And instead of having very specific subviews like UI view, like your label and your image view and gradient view, let's have very generic ones as UI views. So we're going to make that change. And now we're just injecting title label, subtitle label, and all of these are UI views. And then this step is a bit trickier, but we should try and group views that are in the same hierarchy. I think a way to think about this is like, out of this component, what can we identify as a stack or something that combines all of these different things together. Then we remove all the non-layout code, change everything to a function, And after all of these steps, we end up with something like this. So now we have a layout function called makeCard that takes in a background view, an array of card items, and a footer, and does all of the UI change, like all of the auto layout constraints that we want to have in order to get the right view. And now all that's left is to take these static functions that are the building blocks and the layout and put them together. And when we do that, our component becomes, first of all, easier to read. But now, when we construct the view, we could use this layout makeCard function. We create all of the building blocks, put them together, and this is our view. And this is much more powerful than having this picture card view that was shared between everything, because we can pick and mix the behaviors that we want. So the learning here is that with composable UI functions, we can reuse UI with less complexity. We can pick and mix. And it also makes creating new components easier. So if we want to use this type of gradient in something else, we can just call that function there. And now I think it's time for us to relax on the beach and enjoy the component library that we've built. And then we get this message that we have a new business model. So, which is important for the Heroes app. And we're going to add a button to all the literary heroes that lets users buy the book that they're from. Okay, until now, we didn't really talk about actions. So we just assumed that you'll take this view that we create in our component library, put it in a collection view cell, and then handle did select events, probably. How should we handle buttons? So we went with this approach of defining static functions. We can do the same thing for a button. So we can create a button function. In this case, we'll take the text for the button. And because we want to encapsulate everything in a function, we'll take in an action closure. So UI buttons don't support action closures. So we need to create our own heroes button. It's a very simple implementation, and it's not very interesting, but it just, instead of target action, we use an action closure. And then we have our button, and we can use it in our component. So now we added a by action closure to our properties, and we use it inside our function to make the card. That works. And it looks like this. And the takeaway here is, I think a lot of the times when we're tasked with building these type of libraries, we try to think of very simple use cases, and we often forget that about having to handle multiple actions, and it's a bit of a hard problem to solve. Okay, let's go back to our code. This is our literary hero card right now, and I want to focus a little bit on this set of properties. So there are a few things that we need to improve with these properties. First of all, and I think that's kind of like the biggest point around this, we assumed that we had all of the data that we need for our component at initialization, which is probably not the right assumption, especially if we're loading images from the web and we need to load them asynchronously. If we have any kind of state in our app, we will need an ability to update a component that's already initialized. The next part is that we don't really have consistency between components. Components are just something with a view and with a long list of properties, and that makes it hard to know what's a component and what's not a component in our system. And the other part, and this is a bit more subjective, is just around code structure. So if we have everything as properties and we have a very complex component with a lot of inputs and a lot of events, it might be hard to work with. So what can we do better? I think it's time for us to talk a little bit about component architecture. And component architecture is not actually that much different from app architecture. At Spotify, we use a framework called Mobius that we've built that's open source, both in Swift and in Java and Kotlin. And there are other implementations of the same idea in Swift and Redux. This is a unidirectional data flow architecture where the data flows in one direction. More specifically, there are three key roles that objects play in this architecture. We can have a model with a state. We can have a view that renders updates to that model. And we have events that update the model. And usually it's illustrated as a loop where the events, the view triggers the events make a change to the model, and then the view gets updated. What does this idea look like if we apply it to components? So talking about models and events is quite easy. So we take the properties that we had in our component, and move them to a struct. So the first one is the model. It has all of the inputs. So in our case, it's the name and the book and the image. And then we can represent our events in an enum, which is nice because we can have multiple ones, but we can also have associated values if we need them. Okay, what do we do with the component? So the component needs a couple of things. It needs to have a view. It needs to have an update function that takes a new model and modifies the view accordingly. And it needs to have some kind of binding between the action closure from our buttons and some kind of an event handler where the user of the component will be handling this event. So this is an implementation of that. So we create a component that's generic on model and event. We define an event handler alias here, but this is just a closure that takes an event and does something with it. And then we initialize with a view builder that creates the view, with an update function that takes a model and modifies that view, and with an event binding that takes the action closures from our buttons and triggers the right event for the event handler. I know it can be a bit complicated to wrap your head around, but I'll show you what it looks like in practice. That's a bit easier. So now our literary hero component becomes a function in itself. So we have a make literary hero function. We create our building blocks, the image, the button, and the title. We have, inside the view builder, we create the view with our layout to make card function that we've seen earlier. In the update function, we take the model, look at the properties of the model, and apply them to our building blocks. Then the event binding, we say that when the user presses on a button, the event handler needs to trigger the buy action. When we use this type of architecture, we get a very nice and simple API to work with. So the literary hero is just a function you created with the function. Then we have an update function that we can call from anywhere, and our literary hero will adapt to it. And we could potentially do things like animations and transition on model changes. And then we have the on-event part where we put the event handler and handle all of the events from our component. So the takeaway here is that, first of all, component architecture is not so different from app architecture. And even if you don't end up with this particular way of thinking about this, I think it's very important to think about consistency of components and having a clear separation of concerns and clear roles for the different parts of your component. So in this system that we created, we actually have a bunch of files for a component. The component is not just one thing. We can have a model file, an event file, a component file, and possibly even more when we include tests for these things. And we said that consistency is important, and we should think about our users and how can we help them be consistent when they create components. One easy thing we can do is actually use Xcode templates. There are other things we can do with scripts, but this is very simple, and we create a template that whenever someone wants to create a component, it creates all of these different parts for them and give them some kind of guidance about how to use them with documentation. Takeaway here is to think of ways to make it easy for the users of the component library to be consistent. I want to go back a little bit to this API that we ended up with for our button. So it's views cards button, title, action. And I think it might look familiar to some of you because it looks almost exactly the same as the SwiftUI API for a button. And this is not a coincidence. So when we have these static functions and sort of a declarative approach to defining all of the building blocks of our component library, we can align that with the way SwiftUI does things. And at Spotify and with Uncle, we've been really leaning into that. To the extent that we define our own H stacks and V stacks, and even the way that we do layout is similar to SwiftUI. And we believe that when the time comes and we can transition to it, that will make that transition way, way easier. These particular implementations are private, but there is an open source framework that does a similar thing, out SwiftUI from Rakuten, that you can check out and see how you can get the same type of interface as SwiftUI for UIKit elements. And I think that's something that's very useful to consider. Okay, let's have a quick review of what we've done so far on this journey. We started with a picture card that's generic, and we saw that it was a little bit too generic and it was used for a lot of unexpected things in the app. So we pushed a bit further down and created a literary card API that's very specific. but we're still using a generic shared view. And then we saw that this generic shared view over time would evolve to something more confusing. So we broke it down into functions that are generic, and we put them together in a specific way in order to serve this literary card API that we have. But a fundamental problem here is that still we have these generic functions that are used for a lot of things, potentially. So if we have this gradient view, it's used for a bunch of stuff, and we want to make a change for it, we need a way to visualize what that change looks like, and if it's going to break something, and if we want to potentially opt out from that change in one of the components. I think pretty much the only way that I know to do that is to leverage snapshot testing. So snapshot tests are pretty much the easiest tests, unit tests that you can write. In this case, we create our component, we update the model, and we take a snapshot. This generates a bitmap image, which we save, and we compare it to a reference image that we generated earlier. If there's a change, the test will fail, and we'll see a diff to see what changed. And in our use case, we could see, okay, if something changed, do we want that change or not? If we want that change, we can just re-record the reference image. In order to use snapshot testing, you need to use a third-party framework. There's one from Point Free, snapshot testing, which is, we're using that one, and really like the API for that. There's also the iOS snapshot test case from Uber and Facebook who does the same thing. What should you cover in these tests? So we said we capture the state and all of the inputs in the model, so you should cover different models that capture most of the states of your component. And another useful thing you can do is to capture the different traits. So with snapshot tests, we can generate snapshots for tablet, for right to left, for dark mode, for a lot of things that typically take a lot of time to test manually. And again, we'll be able to see how the changes that we make to these shared functions manifest across the entire component library. So takeaway here is that we could use snapshot tests to prevent visual regression and visualize the effect of changes across the whole component library. So we show these snapshots to our team, and very excited, we get these images of all of our components. And our designer thinks that maybe we could use this type of workflow to pixel push the top view and get it just in the right place. So we could, but it's still not a very ideal workflow because we need to make the change, compile the app, run the test, grab the image, send it to our designer, get their changes, and repeat this. And can we do better? Can we have something that's live? And the answer is yes. We could use live previews from Xcode. The way we do that is something that Tim showed yesterday. We can create a UI view representable wrapper for our UIKit-based component that allows us to use it from SwiftUI. And then we can use that wrapper to have live previews. And yeah, this is what a component looks like, the historical card one. And now that we have that, we can pin it and go into our layout code and make changes here to the constants and see instantly what that looks like. And this is a very powerful workflow, and yeah, it's really a pleasure to make these type of changes. It's super instant. So live previews are great for pixel pushing, and you should try and leverage them for your components. But can we do even more with this? So one thing that's very important in a component library is documentation. If we think about the engineers that are using this, it's very easy to go into a folder and see all of the components that exist. But we have other people who are interested in that as well. So we have designers, we have product managers who would want to know if Space Hero component, for example, is implemented, what does that look like? And we need to be able to give them access to that information. And one thing we often don't talk about is that these previews that we created are basically just SwiftUI views that we could use like any other SwiftUI view. So can we use our previews to generate a reference app? A reference app is basically a catalog of everything, all the components that exist. So what we can do is define a protocol called reference preview, and this protocol, all it does is extends preview provider and creates a navigation link from it, which is a SwiftUI link. And then we can use a tool like Sorcery, which is a meta-programming code generation tool, to generate an app for us. So here, this is a Sorcery template that will go through our entire app, see all the types that implement reference preview, and put them in a list. And when we have this, we basically automatically generate a reference app that's always up to date, always shows our previews, and we could have a job on the CI to share that with everyone who wants to know how the component library is done. So we could use live previews to build an always up-to-date reference app and help document all of the components without any effort in maintaining. Okay, we've done all this work. Say you want to do this in your company. What are the challenges of doing it? I think the main challenge is basically about people. So what we want to do is we want a lot of designers and developers and engineers to change their habits and think differently about how they construct views and construct shared parts of the app. There is a model to think about behavior from Dr. B.J. Fogg, the founder of the Behavior Design Lab at Stanford University. And what this model is trying to show is that there's a relationship between ability, which is how hard or easy something is to do, motivation, how much people want to do it, and then the prompts that you use to try and have the behavior that you want. And basically the message of this model is that if something is very hard to do and people have no motivation to do it, it doesn't matter how much you will try to convince them to use it, it's not going to be successful. And I think until now, when we're talking about how do we construct our components, how do we make a component library, we're focused on the ability. We wanted to make things easy to use. And we focus on the motivation, but only in the long-term aspects. We were thinking about, okay, are we creating something that's evolvable and maintainable and will scale well as the company grows over time? And one learning for us is that these long-term benefits are not enough of a motivation for teams. And when we want to have this type of change, we need to think of what short-term incentives we can have for people to use this component library and adopt it. For us, it's been about creating helpers for more advanced voiceover functionality. It was about this like live previews flow that we showed you for making the component. And we're still thinking of more and more ways to provide short-term incentives for teams to adopt it, the component library, and use it. The other part of it is the prompt. So you need effective prompts and pushes for people to use the component library. Here we're talking mainly around education, so things like this talk or like internal training, pairing, so sitting together with the users of the component library and both explaining how to use but also learning from their reactions on how to make things better for them. Then when all else fails, we can use linters to make sure that the system pushes developers for the right level of usage. But again, none of this is going to work if things are not easy enough to use and if people don't have the motivation to use them in the short term. Let's wrap it up. What did we learn? We learned that we could define components semantically to avoid unintended side effects. We learned that we should not forget about the actions, whatever way we want to approach creating a component library. We should consider how components evolve over time. We could use functions for layout and reusable elements to get both a modern API, but also this like pick and mix structure where we can get the behaviors that we want. We could leverage modern tools to have faster iteration. We need to think about how we're going to document our library, and a reference app that's automatically generated is a pretty nice way to do that. And we really need to think about motivation and prompts. And now that we've done all of that, we can finally relax. And that's it. Thank you.
Roy, thank you so much for that presentation. That was awesome.
Thanks.
And I also liked your end screen. It looked like a holiday shot. It's a very positive note to end on.
That's the dream.
Yeah, dreams are good. Traveling is a dream at the moment, isn't it? It's been amazing that we could connect with you for Swift Heroes Digital. Thank you for participating. And hopefully next time we'll see you here in Italy.
I would love that.
Thank you. All right. Well, thanks once again, and we'll speak with you soon.